What's up, guys? Welcome back to another video. Now that I'm a little bit more free, trying to grind these out pretty quickly, so happy to be back again with another video. In this video, we're going to build off of what we did in the last video, which was kind of an introductory video to Matplotlib library of Python. So in this video specifically, we're going to be kind of doing some real-world type examples. So basically combining our knowledge of the Pandas library with the Matplotlib library to create all sorts of different plots based on CSV style data. So we'll start out with a spreadsheet that I'll provide on my GitHub page, link in the description, to gas prices over time for different countries. So with that datasheet, we'll build charts such as the one you see here. Then the second data set that I provided is a list of all of the video game FIFA's player stats. So if you're not familiar with that, basically all of the soccer players, or I guess if you're an international viewer watching this, all the football players in the game FIFA provide all of their like overall stats in the game, and we'll build all sorts of charts off of that. So we'll do like histogram stuff with players' overall rating in FIFA, some pie chart stuff, some more pie chart stuff, a little bit more complex. And then finally some box and whisker chart stuff based off of the FIFA data. And if we have time, maybe one or two more graphs. Before we begin, a couple quick, announcements. First is, if you've enjoyed any of my videos, it'd mean a lot to me if you can subscribe. And also along the same lines, if you don't mind, also following my Instagram and Twitter. Basically, the more followers I get on all my social media platforms, the more content, the more serious that I'll take this, and the more content that I'll produce. And then the other thing is, do not forget to root for the Bruins tonight. I don't actually know when I'm going to post this video, but as I'm making this video, they are about to go into Game 4 of the Stanley Cup Final, so really hoping they can pull out a W and hope that this video ages well. All right, let's get into it. All right, we'll start this video off the same way we started the last video. Make sure you load up the necessary libraries. I'll be editing with Jupyter Notebook using Python 3, but you can be using other IDEs and text editors as well. So we're importing these three libraries, Matplotlib, NumPy, and Pandas. Then the next step will be to download the data that I provided for this. So to do that, go to my GitHub, which is in the description, and we want to download two different files. So the first file we want to download is this gas prices. So the easiest way to to download this is go to the raw, and then just do save as. You want to save it wherever you have your code. So my code, these Jupyter Notebooks for me are in this Matplotlib tutorial directory. So I would save this value here. As you see, I already saved it. And then for the other data file, the FIFA data set, we're going to want to do the same thing. So go back to the main file in the GitHub, click on FIFA data. This one you can't even preview, but just click View Raw, right click, and save as. You want to save it as a CSV file, so a comma separated values file. And you'll also want to save this in the same directory that you have the file that you're writing your code in. Okay, so now that we've saved the data, let's start playing around with it. And if you remember from my Pandas video, the way that we can look at a CSV file with Pandas is we can do something like, we'll call our data gas equals pd.read CSV. Then we need to type in the name of the file we want to read. We've saved it as gasprices.csv, and we should be able to run that, no issues. And we saved this file in the same directory that this Matplotlib tutorial file is in, so that's why this worked. If you save this file in a different directory, you can specify where you saved it. So if you save it in like a data folder, you would specify it with this type of syntax. Okay, gas. So now what we can do is look to see what's in our this data file. So if I just do gas, and this works in Jupyter Notebook, but in another, if you're just using like Sublime Text, you'd have to like print gas, or you could just be looking at the actual CSV file in like Excel. So gas, we have year, and then we have all these different countries and their price in US dollars per gallon for gas that year. So the way I look at this, we're gonna have year as our X input. So, stop texting me. So based on the year, each country has a different gas price. So the way we can access that is we can do something like plt.plot. And so our X data is going to be gas.year. Our Y data is going to be, let's say we start with USA. So USA is all caps here, so I have to follow that same syntax when I'm accessing that. Gas.USA, and then I can do plot.show. And I think already there we'll have a basic graph up and running. So as you can see, yep, this is the basic graph for our data. And we could also add another country. We could do plot.plot. Let's add Canada, year, gas.Canada. I think, yeah. As you can see, now we have two different graphs. And as you can see from this, it's easy to see more easily than just reading the CSV that, oh, okay, every year gas in Canada is consistently higher than in the USA. But we have some problems with this graph. So like one thing that I see that's an issue is all these years, like, I don't know, I think it just makes more sense to be looking at the exact year, especially since this data wasn't like broken up by month. So like, I don't like the x-axis labels. We have no title. We have no real good indicator of what these values mean over here on the y-axis. So we need to start fixing some things up. And quickly to note, if you have like a multi-word name, this format of dot year probably won't work. So you could also do bracket notation to access that field. As you can see, it still works. So if we had something with two names, and I don't remember, let me look at the data again, see if any countries have that. South Korea, for example, like we would have to use this syntax. So I'll actually plot South Korea's gas in this list, their gas prices. So plot, gas, year, gas dot. South Korea wouldn't work. Maybe actually it would work with the underlines. I'm not sure. Yeah, South Korea's having issues. So what we can do is South space Korea. Now we have 3 lines. And wow, yeah, the gas in South Korea is even more expensive. Okay, it's just kind of bothering me mixing these different ways to do this. So I'm going to change this back to year, change this back to year, and only leave South Korea like that because it kind of has to be like that. Okay, so now we have some plots. Let's make this graph overall better though. So to start, let's add a title. So to add a title, if you remember from my last video, and feel free to review that again, we can just use pld.title. I can label this like gas prices over time in US dollars. And so it still doesn't make too much sense because you see all these lines, but you don't know what they represent. I mean, we only know that what they represent because we see the code here. But we should add a legend. And so to add a legend, we're gonna have to first give these plots labels, because if I don't give these labels, watch what happens. Plot.legend. Oh, wow. It worked. I was not actually expecting that to work. I'm trying to think why that is that it worked. Whatever, it worked without needing to add the labels specifically. So that's kind of nice for us. I guess due to the fact that we're reading this in and we kind of, from a nice CSV that already has headers, it probably worked. But in our last video, you had to add label. So I could actually change the label if I wanted to. If I wanted this to just say United States, see that, change it like that. So you can add this optional label parameter if things aren't working for you properly, but for us it just kind of magically did the trick. Okay, so this is looking already a little bit better. I might make the graph a little bit bigger. Let's do that. I can do plot dot figure, fig size equals, say 8 by 5. So that's a nicer size. I think it's more easy to see everything. The legend is a more reasonable size in comparison of everything in there. So that's a bit better. What else can we do to this? Well, we don't have any labels for axes, so we should definitely do that. Also, I really don't like that these tick marks are not exact years. So I think the next thing I'm going to do is change up the ticks. So x ticks. What we can pass in is just the year here. So now it will have a tick for every year that we have data for. Wow, and that looks absolutely fantastic. Yeah, obviously issues with this, too squished together. So what can work well is if I print out gas.year, you see we have, it's part of a Pandas data frame, but we have every one of these years. If we remember, some good old list comprehension, but list iterating syntax, maybe that would be the word, but when you want to get certain items, like the first 5 items in a list, you go 0 to 5, or you could even just do 5. What we want to do is iterate, maybe take every 3 years. So what we could do to do that is, we don't care where we start, so we want to start at the beginning, we want to end at the end, but we want to skip every 3 years. So now we get all of the years we get every 3rd year, which will probably be better when we graph it down here. So I'm going to do that now. So gas year, tick, tick, 3, : 3. Cool. That looks pretty good. All right. I also kind of would like to have exact values here, kind of show exactly where we're plotting the points. So to do that, if you remember the shorthand notation from the last video, we can do stuff like, we'll make USA blue dot dash. So blue is the color, and we want a dot dash. We want dot markers and a dash, a straight line. That's basically what we're saying. Cool, so now we have every 3rd year, but we have points for every time we actually have a data point. So that looks good. We can do the same thing for the other ones. Red dot dash. And what's cool too is you see that the legend changes as we do that. South Korea, let's say green dot dash. Cool, I like the look of this. Still, we need to do some more modifications. Let's add labels to our X and Y axis. So X label will be year. That's pretty self-explanatory. Then the Y label will be US dollars. Cool. So now you can see, okay, in year 2008, South Korea paid approximately $6 per gallon of gas. We're all translating all these values to US dollars, while Canada paid about $4 and the US paid about $3. So that looks pretty good to me, and we can easily add some more countries here. So I could add Australia, for example, and we'll make them, I don't know what color to use. I don't know anymore. Yellow, sure. It might be an ugly color. It's not too bad. But yeah, there we have Australia. It looks like they're missing maybe a data value for 1990. I'm not positive. But yeah, we can easily do this for all of our different graphs. And we could even do something like, let's comment this out temporarily. We could do something like for country in gas. Let's see what happens to that. for that, print country. Yeah, cool. This is giving us all of the different countries. We don't want year, so I'm going to say in gas 1 onwards. Now we have, oh no. Close, close, close. Okay. I'm going to be a little bit hacky here. If country is not equal to year, print country. Now we get all of the countries. And so what we could do with this now is, there's probably a little bit neater of a way to do this than if country is not equal to year. But I'm just trying to show you how we can do this very quick and efficiently. Do gas.year and then country, and we'll let it self-select the colors. But we could, if we wanted to specify marker equals dot, and I think the line style will be fine already. Oh no. Unrecognized character in, oh, okay. Can't just do country, we need to do gas country. Look at that. Now we got all of the different countries in our graph, and you could move. There's ways within Matplotlib to move the legend outside of the graph. I'm not going to go into that right now, but another, I guess, comment that I have is whenever you're doing anything with Matplotlib or anything with Python in general is quickly do a Google search, how to move legend outside of Matplotlib graph. And you'll find probably on Stack Overflow within the first 3 searches, someone that had the same problem as you and found an answer to it. So I always recommend doing that. But this is kind of cool that we were able to quickly graph all of these different lines for all the different countries. And if you wanted to, you could create a list countries to look at, maybe not the best name. And you could choose exactly which ones you wanted to include, and then you would do if not equals year and, or actually you could just do if country in countries to look at. Maybe I'll do this real quick. If country in countries to look at. So you see, this is another way we can graph specific things. Cool, cool, cool. All right, I'm gonna comment this out temporarily and just leave. I'll leave it, I'll push it to the GitHub when we're done with this video. And we'll uncomment this again. Cool. And yeah, you can play around with this style. You can use the shorthand notation, or you can use the longhand notation that we kind of used here. But you also can reference the first video I posted on Matplotlib to really play around with your line graph styles. All right, we're pretty much done with this graph, but I'll add a couple final things before I move on to the FIFA data and doing some other graphs. So the first thing is changing up the font size. I mentioned this in the previous Matplotlib video I did, but I thought it was worth mentioning again. So we can add a font dict to our title, and actually we can add this to any text-based label, so you can also add it to the X label and Y label. And we can do all sorts of different tweaks to our font. I put a list in the description to all the different fonts you can use here if you wanted to change up the actual font type. But I'm going to keep the font type the same. I'm going to change the font weight. I'm going to make it bold, so you see it now. It's not bold, but if I do this, watch what happens. Now it's bold. And let's say I also wanted to change the font size. I would say font size, and let's say it's size 22. So now we have a larger font. Maybe 18 is a better value. So you can do that. You can do that for any of your labels. Another thing we might want to do is when I showed this graph originally, I also added the year 2011. We don't have values for 2011, but maybe you wanted to allow for the ability of that showing up and maybe project where they're going. you could do plus, you take your ticks and plus 2011. That did not work. So this is this is a data frame, so we can't just directly add 2011. So we need to make it a list. Still didn't work. And the problem is the data frame is kind of weird when you add just a direct list. So you can do .toList and now do this. And now you see 2011 is there. And then if you wanted to actually save this graph, remember we can do plot.savefig. We can give it a name. So gas price figure, sure. And remember when we're saving, if you change the DPI, you'll get a higher resolution image. So 300 is a good value. This is going to make a pretty big image. It's going to make a 300 times 8, which is 2400 by 1500 image. But so really you can play around with this video, but the higher the resolution or the higher DPI, the higher resolution image you're going to get. So, I want to save this as a PNG. So if I went into that folder that I had, as you can see, where did it go? Refresh. Oh, I don't know where I'm saving this. Gas price figure, where are you? All right, sorry, I typed this in wrong. Save fig. And you always you can refresh and look at the documentation. I might have gotten, I got an error here. I should have noticed that before, but yeah, save fig, one word. Do that. Now, if I go to the folder that I have these files in, we got gas price figure, and if I bring that in, you see the figure there saved nicely as a PNG. All right, let's move on to the FIFA data. Now that we're done with the gas price stuff, let's move on to using our FIFA data. So we're first gonna have to load it in. So, and if you didn't save the FIFA data, maybe if you skipped around this video, it's on my GitHub page, and the link to that is in the description, and you want to save it in the same directory of the file that you're using to produce these graphs. I'm mixing my words, load FIFA data. Okay, so to do that, we'll just call FIFA equals pd.readcsv, and I believe we called this FIFA data.csv. And let's just check to make sure it's loaded in properly. Cool. And this is actually, I shouldn't have loaded it all. Okay, it's still a preview, but you could do something. If you only wanted to see like the first 5 rows, you can do FIFA.head 5. All right, so you can get a feel for what's in this data. You got like the name of the player, and you should probably recognize some of these guys' names: Lionel Messi, Ronaldo, Neymar. All very good players. I think it's right now sorted probably by their overall. But yeah, it's all the stats from the game FIFA for these guys. And I think it just provides a good set of data to work from. And also I took this data from a Kaggle challenge. So I'm going to link to the original source of the data as well down in the description. Okay, so what can we do with this? So to start off, let's do some histogram stuff. Okay, so what I think is a cool first thing to do is plot the overall skill level here that you see on the right. Just figure out in the game like how many people have above a 90, how many people have between an 80 and 90, etc. So what we can do to do that is we have our data already loaded. I don't have to reload it in, but I can go ahead and do, let's see, plot. And the way that I remember these commands is like I showed in the last video, you can kind of use the pyplot documentation as your your starting point. And then if you're looking to try to do a histogram, look up histogram within that documentation. The link to the documentation is in the description, and you'll find the command hist. So what I can pass into hist is within the FIFA dataset, I'm going to pass in the overall skill level as my input. And let's see what happens when I do that. And then I'll do a plot.show so I don't get all this random stuff. Okay, that looks pretty good. It's already starting to get there. What would probably be more helpful is if these tick marks were centered for each bin that we have. And I'll do that in a sec. All right, we're gonna set the bins every 10 overall skill level points. So like the highest you could be in the FIFA game is 100, the lowest you could be is a 0. So we'll do our bins at intervals of 10 from 0 to 100. So the first bin that we have will be all players that have a skill level between 0 and 10, and it's counting that number. 50, 60, 70, 80, 90, and then finally 100. Cool. So, oh, I didn't do anything yet. Now we can set the bins parameter of the histogram to our bins. Now we got a nice, a little bit nicer of a graph. Now the next thing we're going to do is set our X ticks to be the bins as well. So now it's nicely labeled. Each interval corresponds exactly with what we have here. But it looks like we have some unnecessary data. So it looks like there's very little players over here. So maybe I'll limit this, start at 40 and go up to 100. And what's kind of crazy is, you know, the players that are over a 90 are really a rarity, because you can't even see that bar from the 90 to 100 range there. So let's do a little bit. We got a title, same way as before. We got a Y label. So I'll do a Y label real quick. Number of players. And the X label would be the skill level. And then we could add a title that would be like distribution of player skills in FIFA. I think it's FIFA 2018, might be 2019, not positive. So that's a cool little visualization, and you can get more into details, like to actually see that there are some values there. You could change up your Y ticks to be, let's say, 0 to 100. Okay, that didn't work. I guess it's kind of tough with all of these players, but if we did move it from like 80 to 100, you see that, yeah, there are actually players that are above a 90. It's just very, very few compared to the amount of players in the game. Another thing you could potentially do is maybe break it up, use the data, and only look at the stats of players on certain teams, and then you wouldn't get all of the noise, I guess, in the lower skill levels that like put all the people in here. One little modification we could make to this is, let's say we wanted to change the color of our bar. I could set this, I could set it to red easily like that, or I could set it to a hexadecimal value very easily. And what I recommend, whenever you want a certain color, what you can do is just like do a Google search for a color picker. And as you see here, I can just move this bar around, and no matter what color I want, so let's say I want this greenish color, I copy that hex code, hide this, paste in the hex code, and now I get that green color. I kind of like the bluish color, so I'm going to go with that. But yeah, you can play around and get any color you want with Matplotlib. All right, let's do pie charts next. And just to start off, I kind of mentioned this, the histograms, but to like figure out how to do a pie chart, I usually just start at this documentation, look up pie, plot a pie chart is right there. And then with this page, I can kind of get all the details of what I can pass in and what are the parameters that I can play around with. Yeah, a lot of good stuff here. Okay, so the wedge sizes is our X, and that's what we're going to input here. So what does that look like? Okay, so I'm going to just output some of our data again. And what I think we're going to do for this first chart is one of the components of this, I guess we can't see it here, but if you opened up the full, yeah, I can't see all of it. If you opened up the full file within like Excel, you would see that one of the parameters we can have is preferred foot. So if I look up that, you see that left or right, it's whether you play left or righty in soccer. So what I think would be interesting to do a pie chart on is the percentage of people that play with their left foot versus their right foot. So how would we do something like that? Well, we can count the number of people that play with their left foot by doing the following. And this plays into the stuff that I taught in that we went through in the Pandas video. But we can use the .loc to kind of like look up the data set or kind of filter the data set by a specific condition. In this case, for left, we want the condition to be, apologize one sec. We want the condition to be if the preferred foot column is equal to left, then we want only the data that this condition holds. And because we're going to need to pass this into a pie chart, what we'll want to do is get the count of that. And I believe this count gives us an array. I can probably check. So let's see, what is the left? Yeah, it's like an array here. So if we do count 0, we'll actually get a number. As you can see, 4,211 players prefer their left foot. And so we can do the same thing with right. It's FIFA.loc, FIFA preferred foot equals right. Get the count of that, and then because this returns a data frame, we have to take we'll just take the first element, which it will be a number. And let's see how much, like right. Okay, so considerably more people preference their right foot than their left. That makes sense. Okay, so now how do we do the pie chart? Well, we can do plot.pie. This is from the documentation. And I guess I kind of jumped ahead, but you might like think, maybe I can just go ahead and do FIFA preferred, I can't even spell. Of course that won't work. Foot, and like figure that I might just plot the pie chart while doing that. But it gets messed up when you don't pass it numbers. So what we need to do is pass in a list of numbers. So what we can do is left, comma, right. So now we have 2 values, and I'll make a pie chart out of these values. Look at that, cool. And I'll do plot.show. One thing I'm noticing is these colors are really ugly, and also nothing is labeled right now. So going back to the documentation, you can see labels is a list, sequence of strings providing the labels for each wedge. We can pass in that. We can also change up the colors within a list as well. So let's do that. So labels, we'll do equals left and right, and we'll pass those into our pie chart. Do labels equals labels. Cool. So now at least we have like relative percentages. I mean, we don't know the exact percentages, but you have an idea just based off the graph. If we added in colors, we could change this ugly orange from being there. So you could pass in 2 colors. Let's say like, we're gonna just use some hexadecimal values. I'm just typing in these in randomly. And now I have to pass in colors here. Cool. Now that looks all right. Maybe you'd want a little bit more contrast, but it doesn't really matter too much. You can be the judge of that. If I do auto percentage, this should, I forget exactly how to format this. I'll have to check. So auto percentage, format percent, would be format. So we can use a percent notation here. So we can do %.02f, and basically it'll just fill in whatever value is for the percentage with 0.2, 2 decimals of floats. And I guess I screwed that up. It probably has to be a string. Cool. So now it actually gives us our percentages. So 23.19% of the people in the FIFA game prefer their left foot over their right foot. And if you want to actually see percent on that, it's a little bit weird. You can just do %%. Basically, if you just did percent, I think it would bug out because it's expecting specific notation. Basically, by doing 2 percentage points in this notation, it knows you actually do want that percentage sign. All right, and then we could add a label, a title, as we've done in the past. Foot preference of FIFA players. Cool. And there's a basic pie chart. I'm trying to think if there's other things I should add to this. We'll get into a little bit more complicated stuff in the next pie chart that we'll build. So this is a pretty simple pie chart. Let's make another pie chart. All right, pie chart number 2. So in this one, what we're gonna do is look at the breakdown of the weights of the FIFA players, and we'll plot it as a pie chart. So, I mean, okay, let's look at what the weights look like. So I'm gonna print out weight here. Okay, so we have a list of all these weights. What we can see is that and note that they're in pounds. They're not in kilograms, as many of you guys might expect. They're in pounds, but initial step you could do to this pie chart would be to convert all these values to kilograms. That'd be a fun little exercise. But okay, we have all these pounds. And one thing I immediately notice is if we're trying to count ranges of these pounds, it's gonna be tough with this pounds string attached. Is there anything else I notice here? No, it's mostly just that, but okay. So basically what I want to do is reset the weight category to not include these pounds and just be the number. So this is going to be a string right now, and we just want this converted to an integer. So let's try to do that. Okay, so we're going to reset the weight column. And what we're going to want to do is strip off. So X here, we're going to do X for X in FIFA.weight. So X in this case is going to be a string. So we can do strip LBS. So that will give us just this part of the string for X in FIFA.weight. Let's see if that works. Float object has no attribute strip. Interesting. I was expecting that all of these would be strings to start with, but because they're not, what we can add is an if statement within our list comprehension. We're going to just say if type x equals string. I'm guessing maybe there's a couple empty values or something, so we're just going to kind of ignore those. And then else x. So if type x equals string, we're going to do this, else just leave it as is. That's what we're saying here. Let's see if this works. Now we print out FIFA.weight. Cool. And we're going to take the first value real quick. And notice it's still a string, so what we're actually going to want to do to this line is surround it with the int block, which will convert it to an int. Now if I look at this, FIFA.weight 0, we get it as an integer value. I don't know why it's giving a decimal here, but it should be an actual value. And you notice because it's a 0.0, we know that it probably is being read as a value. Okay, so now we have these values set right. So let's start counting things. So we're gonna start with light players, and we'll say light players have a weight under, this is kind of arbitrary, but we're gonna say that they have a weight under 125 pounds. And then we're gonna count that, just like we did in the last example. Then the next condition we'll do is, I guess, medium light players. That will be above 125, greater than or equal to 125. Then we need an AND condition. The AND condition, and the way we're going to format this with our Pandas notation is like that. And this is probably review a bit if you did watch through the Pandas video that I did. And FIFA.weight is less than 150, let's say. So now we're getting only the rows that have both of these conditions true. We're going to count that 0. Keep doing this. I'll probably speed this up when I edit the video. I'm going to just get 3 more categories. All right, cool. So we have 5 different weight categories, and I can like print these out. Oh no, invalid syntax. What did I do? Oh, didn't end that. 369 heavy people, medium heavy. Let's see if this is a valid number, 4,000. So yeah, it makes sense that there's more between 170 and 200 than there are people over 200 in the league. It's kind of tough to be a soccer player over 200 pounds. Okay, so let's now plot this. So what we want to plot will be our weights, and I'll make this an array. Light, light, medium, 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 heavy, and heavy. And our labels. Can't type today. All right, so plot.py weights. Let's see what this looks like. Cool, it looks pretty good, but it has no labels right now. And I'm going to do a plot.show. So we need to add some labels. So under 125 is the first one. 125 to 150 is the second. 150 to 175 is the third. And 175 to 200 is the fourth. And finally, over 200 is the last. And we'll pass these in with our pipe chart. Okay, cool. So now we have all these labels. One thing I don't like, and this is a good little thing to know, is I don't like the default color scheme. And instead of passing in all 5 of my own colors, one thing you can actually do is, I don't know what I just typed in. I didn't mean to do that. I'm getting ahead of myself. Is there's a plot.style. And so instead of the default, which is currently set, so as you can see, it stays the same when I do that, we're going to use the style of ggplot, and I'll link a list of these different styles in the description. So I personally like this color scheme a lot more when I change the style of our plot. Okay, so that's pretty good. We can also add the auto percentage as we did with the last example. So percentage point to F, percentage, cool. But things are a little bit ugly in this case. The things are squished together. So how can we resolve this problem? And really, if you go into the documentation, you'll see there's a lot of these weird names, and you might not know what everyone means. But if you kind of look up, like if you did a Google search like pie chart, Python, numbers getting in the way of each other, you'd probably find some different solutions. So one solution we could go ahead and try would be setting the percentage distance. So the percentage distance is the percentage distance from the center of the graph. So if I did percentage equals percentage distance equals 0, you'd see everything's right there. So instead of that, we'll do like 0.8. So this comes 0 to 1 is within the chart, and you could even do, if you wanted to, like 1.5, and that would be values outside the chart, but 0.8 was a good value that I thought. Okay, so this maybe makes it a little bit better. These numbers right here that I'm highlighting aren't as squished, but they're still not great. So the other thing we can actually do is use this explode property. And what explode does is it breaks the graph apart a bit. And so let's see what that does. So we need a list that's as big as our, this could be a list. It can be a tuple. I'm going to set it as a tuple. That's what I did when I was playing around with this. Shouldn't matter. 0, 0.4. These are the values I want to get to, but we'll start with doing them all 0.1, and I'll reason to why I got to the values that I got to. Okay, so explode equals explode. So this is going to split the graph apart so it's not actually touching. So you see that. So that's cool, but really we don't need everything exploded. We really just need these values that are very close together to explode a bit. So what we can do to that is, all right, so we want under 125 and over 200 to be exploded a bit more. As you can see, those correspond to our labels here. We don't really need 150 to 175 to explode at all because that's pretty set. We don't really need 175 to 200 explode. So what does this look like now? And we'll have this explode a little bit. This is this 12.61%. Cool. And I think that this looks decently good now. You can more easily see the different slivers, and I guess it's tough because this sliver is so small, the under 125, but I think that you can more easily read this than you could when all of them were compact together. And as in the other examples, we could also add a title. So weight distribution of FIFA players. And we would want to say that this is in pounds. Cool. And also, as you notice, because I changed the style, the header actually changed too. So that's one thing to be a little bit careful with the styles, but sometimes they can be very helpful. All right, because this video is getting kind of long, we're going to end it with one more graph. But if there's other types of graphs that I didn't cover in this video or my previous video that you want to see, let me know in the comments. So we're going to do a box and whiskers chart. And really the question we're trying to ask here is, how can we compare teams, like how good two different teams are in our set? So looking back at our FIFA chart, let's print that out. So you can see that all of these players have a club. So we're trying to compare the relative strengths of different clubs. And so I thought that a good way to do that would be to use this box and whiskers chart, which shows your highest player, or it shows your highest score. If you have a box and whiskers chart, it will show like the max, it will show the mean, and then it'll show a box around where the middle 50% of scores or values were. I think that's a good way to compare a team, where you can kind of see, okay, where's the best player at, where's their worst player at if everyone got injured, and then the middle box is kind of like the core of the team, like how good are they? So I think it's a good way to potentially compare two different teams. Maybe you can disagree with me, maybe there's a different way you would recommend, but that's what we're going to do in this example. So to start, let's take a couple teams and count their overall scores for that club. So we'll start with, what's a good team to start with? Go up top. We'll start with FC Barcelona. So we're going to do Barcelona equals FIFA.loc. So we're going to filter out all of the rows that have people from Barcelona. So we can do FIFA.club equals equals FC Barcelona. Yeah. Cool. And let's see. And then we want, when we do our averaging, we're going to want to take their overall score. So we can just filter by that too. So now if we print out Barcelona, because we're comparing the overall scores, I think that's the most useful metric. You see we just have a list of all the players on Barcelona, their their overall performance in FIFA. Cool. And we could do that with another team. Let's say we do Real Madrid. FIFA.club equals equals Real Madrid. And we want to take their overall values as well. Cool. So this is two different values. We can see Madrid here and all those values. Okay, so now let's plot a box and whiskers chart for that. So to do that, we do plot.boxplot. We pass in Barcelona and we'll pass in Madrid. So these are all the values for Barcelona and all the values for Madrid, and corresponds to what we see here. So it will know, this function will know that it needs to make a box plot off of that. So what does that look like? Okay, one thing I noticed too, this is also a residual effect of changing the style in one cell. Style is still changed. I'm going to change the style here back to our default style. So default style looks like this. Graph doesn't really tell us too much right now, but we'll get it to look a little better in a second. And I want to do plot.show so all this stuff is not there. Okay, cool. So this is a comparison of the two teams relatively. You can see they're pretty dang even. I'd say Barcelona has a slight advantage. Seems like its box is a little bit higher than Real Madrid's. And also their best player is ranked better than Real Madrid's best player. But it's kind of annoying when it just says 1 and 2 down here. So let's add our labels. So it's a list, FC Barcelona and Real Madrid. And then we can go into our box plot. It has a labels property, and you can double check the documentation to see this. Labels, labels. Cool. So now we have our two different box plots. And so these two teams with this comparison, I would just say that they look pretty similarly matched. Like they could go head to head, probably be a pretty good game. Where you really see kind of the coolness of visualizing this data with a box and plot and like comparing two teams is when you take a team that's not as strong. So my local team here in Boston is the New England Revolution. They're an MLS soccer organization. So if I also pass in some scores for them, and their shortened name is the Revs. So I'm going to just call them that instead of typing out the whole New England Revolution every time. And what am I trying to say? New England Revolution. And we want to take their overall. And you could look at all the different teams in the data sheet and get like a certain team that you wanted to look at. Pretty easy. You just have to be careful that you type in everything properly. And apparently I did something wrong. Oh, okay, yeah. We also want to pass in the revs here. Cool. So now we have 3 teams, and you can see that the New England Revolution is significantly worse than Real Madrid or Barcelona, which is what we were wanting to show. Let's add a title here, and we'll add some style to this chart as well. Professional soccer team comparison. And because I'm from the States, I call it soccer. Yeah, you probably call it football. But that is besides the point. FIFA overall rating. Overall rating is our y-axis. And we have our teams down here in the x-axis. That looks pretty good to me. Okay, what we could also change up potentially would be our tick marks. Okay, or we could change the figure size. Maybe it would look better if it's stretched out a bit more along the y-axis. So we'll change our figure size a bit. So plot.figure, fig size equals, we'll have the y dimension be greater than the x. And as you can see, now it looks like this. And this gives us a little bit more detail in the actual scores among the two teams. But yeah, you can still see the New England Revolution is not as good. And also this name is kind of running into each other. So I'm going to shorten New England Revolution to any revolution to just kind of make it a little neater. Cool. All right, so the final thing we're going to do is add a little bit of style to this graph so it looks a little bit better. And you also, if you wanted to, yeah, feel free to add more teams to this and like really see the differences between soccer teams and FIFA. But we will add some color around the perimeters of these boxes. Maybe make this line a little thicker. This represents the median, the orange line. Okay, so what I found to be the best way to do this is I'm going to save boxes as the result of this plot. And then basically what we can do is this will store the 3 different values we plotted here. So it'll help us style each individual box a little easier. So for box in boxes, boxes. So you're getting the box parameter from what was saved here. We want to set the color. And this also kind of shows you that there's different ways to do these things. Like I could have passed color in here. The problem with passing color within here is it would make everything the same color. So if you wanted to like go ahead and change a specific box, like and have a list of colors, it's easier, or I guess maybe colors is not the best example because colors probably would allow you to pass in an array. But for certain properties, it's hard to set just one value at a time. So I'm going to go ahead and set the color here. So now you see that we have a different color around our box. And they're similar to boxes here. There's another parameter for like the long strike here and the long strike here. The whiskers of the box and whiskers plot. But I think it could use to be a little thicker here. And so to do that, we can do line width equals 2. And all of these parameters I'm finding from the documentation. Okay, cool. So set edge color basically. And let's say we wanted to change the fill color. So change fill color. And you could, as I said before, like you could iterate through these and through a list and like each time set a different color for each of these. So change fill color, we could do something like set face color. We could all do this in one line as well, but kind of just showing different ways you can go about things. Face color is another property. This actually changes the inside of the box. So what happens when I do E0, E0, E0? This is a grayish color. Unknown property face color. And this was something that I found super annoying when I was trying to do this. So if you're trying to set the face color of a box and whisker chart, it doesn't recognize, it can't like recognize this property face color for whatever reason by default. So you actually have to set this patch artist property to true to allow you to change the face color. So now we have these graphs. I think that looks a bit better. We could also change up the median line. So you could do it within this format, or another way we can do it is one of the properties of box plot is median props. So you could also pass in like a dictionary of median props. And so we could pass in a line width here too. So let's say we wanted this line to have the same thickness as the outline. Pass that in, and there we go. A lot of the styling stuff, it's really a matter of Google searching, really. Like, you can look at the documentation, find some things from the documentation, but what I find is sometimes quicker is to say, oh, how do I change the outline color in a box and whiskers chart? Google search that, find a Stack Overflow post, and then like from there figure out I can do this type of technique. That's what works usually well for me. All right, so yeah, now we have these three teams being compared. I'm going to shrink the graph a little bit so you can see better. And I think this is a kind of a cool way to visualize how teams compare in FIFA. All right, I'm going to end the video here. Hopefully these graphs were helpful. Hopefully it's helpful to combine the pandas and like the CSVs with the Matplotlib library. If you found this video useful, make sure to throw it a big thumbs up, and also don't forget to subscribe because I'll be posting a lot of videos in the near future. Also, feel free to leave a comment if I didn't explain something well enough, or if you have a future video idea that I should work on. Let me know those things, that'd be great. But yeah, that's all I got. Thank you for watching. Peace out. I don't know what I'm doing right now. Yeah, peace.